Hi everyone. Today we want to learn how can use the Sentinel-2 satellite for monitoring the seagrass. The seagrass are the marine flowering plants found in the shallow coastal areas and play a crucial role in the maintaining coastal ecosystem. These plants provide important ecological services such as the carbon sequestration, habitat for marine species, and shoreline stabilization. Monitoring the seagrass health is essential to understanding the impact of climate change, pollution, and human activities on the marine environments. We used the Sentinel-2 satellites here, and it is a part of a European Space Agency Copernicus program, equipped with a multispectral sensor that can provide a high-resolution image of Earth's surface, including the coastal and marine areas. And the satellites can capture key data needed for seagrass monitoring, especially through the use of a Normalized Difference Vegetation Index or NDVI, which helps distinguish the vegetation from non-vegetation area. And so how Sentinel-2 can be used for seagrass monitoring? Seagrass are typically found in the shallow coastal areas and their health can be assessed by monitoring the vegetation cover as well as the water quality. And Sentinel-2 high-resolution multispectral imagery allow to calculating the NDVI, and which is index used to measure vegetation health. And NDVI values range from -1 to 1, where positive values represent the healthy vegetation. In the context of a seagrass monitoring, high NDVI values are typically found in the seagrass beds as they have a high chlorophyll content. By comparing NDVI over time, we can detect change in the extent or health of a seagrass bed, which may indicate environment stressors such as a pollution, temperature change, or physical disturbance. So we going to step-by-step implementation. First, we define the area of interest. I selected the area in south of north of Tasmania. If we run the code, we zoom here, the island area. And you can change this based on your needs. For example, Bali, Indonesia, and other areas you want. This is a Tasmania area. And after this, yeah, we need to load the Sentinel-2 satellite. We use it the image collection Sentinel-2, and we use it this dataset. You can, yeah, investigate more. It's available from 2017 until 2025 with the 5 days. You can find the bond description here and user guides here. So we need to filter the bonds based on an area of interest, and we want to extract the this data range in 2024, and we need to filter the cloudy pixel. I use it the 1% because we need the non-cloud images. And after this, we need to calculate the mean value of this, the mean image over the selected time period need, because this composite image represents the average reflectance value of the area over the defined period. And I calculate the NDVI with band 8 and band 4 with the normalized difference. NDVI is used to measure vegetation health, as I mentioned it before, and it is calculated using the near infrared and red bands of Sentinel-2 imagery. And values close to 1 indicate healthy, and close to 0 indicate the water or barren land. And after this, I created the land masks with the NDVI. Seagrass areas are often mixed with land, so A land mask is created using the threshold NDVI values, and this mask helps separate land from non-land areas, seagrass and water. And I mask the water areas to detect the seagrass. By using the threshold on NDVI, you can mask out areas that are likely the water or seagrass bed. In this case, an NDVI threshold of 0 help isolate the water areas and seagrass bed. And after this, here we can use the display the result. After processing, the result are isolated in the map and to show the true color composite, NDVI, seagrass detection area, and land areas. We need to only detect the NDVI and display these three layers. If we run the code for different layer, we need to define the mean and max. For NDVI, we define the -0.5 to 1 with palette white and green with name of NDVI. For seagrass, need to detected by NDVI threshold. I used the mask value for this, and I used only green color because it is a binary, and I named the layers detected seagrass areas. And I used the mean image of a two-color composite as to mean with a minimum 0 and maximum 115. And after this year, for the seagrass, I used the masks of a seagrass with only I added twice here. If I run again, yeah, I have a two color composite. Need to, yeah, yeah, we have a three color. The first one is a two color composite. You can see we need the high quality and non-cloud image, and after this, yeah, we can calculate NDVI and using the thresholding method detect the seagrass area. Yeah, this is a seagrass area detected in North Tasmania. So what is the importance of a seagrass monitoring? First, environmental health. Seagrass are crucial for maintaining biodiversity and improving the overall health of a marine ecosystem. And monitoring their health can provide early warning of environmental stress, including change in water quality, pollution, and temperature. And second application is a carbon sequestration. Seagrass are known to be a significant carbon sinks, playing the role in mitigating climate change by absorbing CO2. And monitoring these areas is key to understanding their role in the carbon sequestration. And other application is marine habitat. Seagrass beds provide shelter and breeding grounds for numerous marine species, including fish, crustaceans, and invertebrates. And the health of a seagrass bed is directly related to the productivity of a marine ecosystem. Another application is the coastal protection. Seagrass help stabilize sediment and prevent the coastal erosion. By monitoring the seagrass health, we can assess their effectiveness in protecting shorelines. By leveraging Sentinel-2 imagery and Google Earth Engine, you can use this code in any area of interest with any date. Thank you for your watching. Please subscribe and like our channels.